Okay, so far we've looked at the introduction to Java programming. We've talked about the types of applications, the additions, and so on. We talked about the JDK, the JRE. We looked at the interface, how to set it up, and also the we wrote our first program, Java program, and then we saw the program structure. Last week, I gave out a video from one of the classes I had last academic year for you to watch. I want to believe everyone has watched and practiced that video. You were not only supposed to watch, but you were supposed to also practice. You're supposed to also practice um, what was happening in that video. I hope you've done that.
Yes, yes, we want it.
Okay. I am saying this because if we go by the course outline, what is in that video is supposed to be what we are supposed to learn, or we're supposed to be learning today. Okay. Um, there was a project for to print a receipt, okay, a formal receipt or an invoice. So that was what that project entails. So today we'll go back, we'll look at introduction to object-oriented programming and then Java fundamentals. Okay, so we have a lot to look at today. Um, all right, so believe we can start. So object-oriented programming. Object-oriented programming. Now, object-oriented programming is a concept in it's or let me just take it this way. Anytime you are learning a programming language, you start from the level as a novice, okay, or a beginner. So as a beginner, you learn things like um, data types, operators, and so on. You learn things like how to handle um, yeah, Blay, your hand is up. Do you have a question?
Sir, please, I had a question, but I've answered it myself. Thank you, sir. Please can go on.
Okay. So you look at things like operators, how to use operators, how to um, handle control structures, how to make decisions in your program, and so on. Okay, so all these are part of how to write a program, okay, as a beginner. Okay. Now, programming languages are structured into or are divided into different domains. So there's um, functional programming, there's uh, uh, declarative programming, and so on and so forth. Okay. So in the evolution of programming languages, we know of the machine learning, the assembly language, machine language, assembly language, and then procedural language. So procedural language, um, which is one of the concepts. Okay. So procedural language is one of the programming language paradigms that follows basic programming fundamentals. Okay, so if we talk about procedural language, we are looking at language which follows procedures, or what we can also say, it follows things like functions. Okay, so you write a program to follow a function. You write a program to follow a particular procedure. Okay, then procedural language also focuses on tasks. They are task-based. You write a program to perform a task, and then that is all. Sometimes you can be the task can be treated repeatedly, and so on. Okay, then it also follows a top-down approach. Okay, and the codes are there is reusability of the code is limited, and a few other how do we call it, details when it comes to procedural programming. So a typical programming language that follows the procedural programming is C. Then we have the Pascal programming language. There's Fortran, there's BASIC, okay, there's COBOL, and so on. Those are all procedural programming languages, and they evolved from the assembly language. Okay. Now, then there came the object-oriented programming language, or object-oriented, yes, programming languages, or object-oriented programming. So object-oriented programming is going to another level, okay, where it's looking at how programs can mimic objects. Okay, mimic things like objects. Now, objects can be seen as an entity. Okay, so if you are writing a program, it's not only about focusing on how a task can be performed, or programs being arranged around some procedures, okay, but rather you organize the program around what we call objects and classes. Okay, so anytime you hear of object-oriented programming, the first thing that should come to mind is that your program is focused on objects, how objects focuses on objects that perform tasks. Okay, it's not just about how the task can be performed, but objects that perform those tasks. Okay, and you can also picture it in a form of classes and objects. Okay, so if you read over here, it said object-oriented programming means reasoning about a program as a set of objects rather than as a set of actions. Okay, so you are seeing it not that as a set of actions. So you write the function, okay, a function to add two numbers. So you declare the function, you give it the various parameters, you write the statement, okay, add A, or a sum is equal to A plus B, and then the function is always there, it's being reused. Anytime you want to add two numbers, you use the function. So those are seen as sets of actions. Okay. Now, object-oriented programming is saying that we should view programming as an object that can perform the task. Okay. Now, if an object is going to perform a task, then it needs two things. First, it needs what we call data, and then it needs what we call a method. It needs data, and it also needs a method. Now, if you look over here with the image I have here, the data can be seen as the attributes, and the method is the behavior. So for every object or every entity, okay, it should possess these two unique should I say attributes? Attributes is already here, but it should have these two things. It should have data, that's the attributes or properties, and then behavior or behaviors. So the behavior, you can also call them the methods or functions, or we can also say they are the operations. Okay. So object-oriented programming is looking at program as a set of objects. Okay. Or it focuses on set of objects and then rather than set of actions. Now it follows what we call the bottom-up approach to your program design. It supports things like data hiding, what we call encapsulation, which are things we are going to talk about. It supports code reusability through the use of inheritance and polymorphism, which is also one of the pillars we are going to discuss. Then it's suitable for large and complex application, okay, and scalable application. So they are unlike the procedural, which are for simple and small applications. Object-oriented programming goes a step higher, okay, to help you with large or complex applications, okay, and scalable application. So you are developing application. It should, if the size of maybe the resources are increasing, the application should be able to what? Scale to the increase in the resource, okay? And then, like I said, it supports inheritance, polymorphism, and so on. Okay, so programming languages like Java, C++, C#, Python are all examples of object-oriented programming languages. Okay, object-oriented programming languages. Okay, so for every programmer, the concept of object-oriented programming language is when you see yourself moving from the level of a beginner to an intermediate level in your programming, in your development, okay, as a programmer. Are we all here? Are we all here?
Yes, sir.
Your
Yes, sir.
ability, your ability to be able to understand the concept of object-oriented programming, okay, shows that you are moving from the level of a beginner to an intermediate level in programming, okay? Then from the concept of OOP, then you move to another concept we call data structures and algorithm, which is also another key course, okay, which you need to learn and understand in programming, especially as a computer science student. Okay, then once you get to that level, then once you understand, grasp those concepts at that level, then it means you are approaching an expert in a particular language. Okay, you can call yourself an expert in a particular language. Okay, but all this comes through practice. Okay, constantly practice, focusing yourself, dedicating yourself to a particular language over and over again. Just as people learn the natural languages. Okay, yes, we all speak English, but there are people who are fluent, okay, in English in terms of speaking, writing, okay, and yeah, they are fluent, they are good. So you can see that those people have taken the English language to another level. even though at the base, yes, we are all learning English as our first official language. We all speak. But there are people who have gone to another level with the English. They learn the phonetics, they learn the structure, the syntax of the language, they learn all the basic things that we need to know, and even the complex ones regarding the language. Okay. All right. So with that said, let me just talk briefly about OOP, and then we'll go back to look at uh, the fundamentals in Java. So OOP simply stands from object-oriented programming. It's a programming paradigm that revolves around around the concept of objects, and it brings modularity, reusability, and maintainability to software development. Okay. So it starts from the level of understanding what objects are, then to what a class is, then inheritance, then polymorphism, then abstraction, then encapsulation, then also interfacing. Okay. So we'll look at this two level. In fact, this semester, we'll look at it all the way to polymorphism, inheritance and polymorphism. And then we'll continue the rest, abstraction and interfacing from next semester. Okay, where we look at other concepts in Java 2. Okay. So let's look at what a class is, then we look at what an object is. Okay, then we move into the fundamentals, but we'll revisit this topic where we now come and implement the codes regarding how you perform inheritance and polymorphism and so on. Okay. So basically, a class, if we say a class simply is a blueprint or a template that defines the attributes, that's the data, and then the behaviors, that's the methods and functions that an object of that class will have. Okay. So it defines two things. First, the attributes, and then the behavior. Okay. So just see a class like, yes, it says a blueprint or a template. Okay. So you want to build a 3-bedroom house. You want to build a 3-bedroom house. Okay. Before you build that house, you should have a blueprint. Okay. There should be a template or a plan that shows, okay, this is the part of the land where we are going to build the house. The house will have this number of windows, will have this number of doors. The house will flow to the top. We want to build a 1-story. We want to build it this way, that way. We want to hide the roofing. We don't want the roofing to be on top. We want to hide it and so on. So the plan will give you a picture of how the building will look in reality how the building will look once you are done. Okay. So what happens is that anytime in your program you write a class, that is what the class is doing. It's just giving you a blueprint of the object of that class. Okay, a blueprint of the object or a template to the object. Okay, now the template will have attributes and it will have some behaviors. So for instance, if we take that class, what are the attributes? What are the behaviors? We should know them. Okay. Then it says here that an object is an instance of a class. It's an instance. If we say something is an instance, okay, if we say something is an instance of a class, sorry, if we say something is an instance, what does it mean? Instance simply means it's an example or it's an illustration or a case, okay, of the class. So the class is a template. So now if we see a 3-bedroom house, we will say that, oh, this 3-bedroom house that I'm seeing is an instance of that template, of that class that I saw. Okay. Or it's an example, or it's the illustration of the class that we saw. Okay, so it says it represents a specific entity with its own unique attributes and behaviors. So an object has its own unique attributes, and behaviors. Okay. So if we say an object-oriented programming is an entity. Anything can be described as an object. For instance, you are using your phone. Some of you, I'm sure, are on your phones right now for this Zoom session. Your phone is an object. Okay. Some of you are on your laptops or your PCs. Your PC is an object. You are sitting on a chair. That chair is an object. Okay. You are in a building. That building is an object. Okay. You are using a software to run this application, to join this Zoom session or this online session. So that software you are using is also an object. Are you all following?
Yes, sir.
Yes, sir.
Yes, sir.
Anything at all can be described as an object. Anything at all. Your pen you hold
Yes,
is
sir.
an object. A software you are running is an object. Okay, so don't see the object as any physical entity like the table, your phone, and so on. But software applications, and so on, mobile apps, desktop application, they are all objects. Okay. All right. So that being said, let's quickly look at this example here. But like I said, we'll revisit this topic again in week. Let me check from our course outline. Yes, we'll revisit this in week 8 and week 9. I'm sure by week 8, we should be there. I'm reconsidering when we will have the mid-semester exams. But probably by week 8, we should be looking at objects and classes again. And then we will zoom straight into inheritance and polymorphism. Okay. All right. So let's take a human being as an object. Sorry, as a class. Okay. So class human. Class human. Now, if a human being is a class, the class is human, right? Please pardon my handwriting. Now, the human has attributes. So every human being has an attribute. So I'll use A for attribute and B for behavior. Okay. So they are attributes of a human being. A human being has height. A human being has a height.
Weight.
It has a weight, as we can see there. A human being should have a complexion. Okay. Complexion, color of the skin, the color of the eye, the color of the hair. So all these are attributes, things that uniquely define or describe the human being. Okay. A human being has an eye. So what's the color of the eye? Okay. It has hobbies. So you can see down there, there are hobbies. So these are attributes that uniquely describe the human being. Then we have behaviors. So every human being has a behavior. Okay. So behavior, the person can run. How does the person run? The person can sleep, sleeping, jumping, okay, and so on. Those are behaviors, things that behaviors. So these are like conducts, things the person can do. Okay, so more like acting. Okay, so sometimes I try to, in my way of understanding some of these things, is to see the attributes as what describes the class, and then the behavior as the action part, okay, of that particular class, the action, things that are being controlled, the action and the reaction or reaction of something. Okay. So that's how the behavior should be. Okay. So we see all this as the attributes and behavior of a class human. Then we can now create an object from that class. So if you realize that, okay, all these attributes can be attributes and behavior of a human, then we can create an object from that class. So we can say Clement Mensah. Clement Mensah is an object of the class human. So Clement Mensah is an object of the class human. Why do we say so? Because Clement Mensah has the instances of the class humans. What are those instances? He has a height. So maybe his height is 162 centimeters. Clement is dark in complexion. Are we here?
Yes, sir.
Yes, sir.
Okay. So Clement runs. So can Clement run? Yes. Does Clement sleep? Yes. Okay. Or we can look at how Clement sleep. So that's the behavioral part. How does Clement sleep? Or does he even sleep at all? Yes. Okay. So anytime we are describing classes and objects, we always have to see it from this perspective. Okay, so we say, okay, this is a class has attributes, has behaviors, and the attributes are the same as what we call data. Data. And the behavior is what we call the functions or the method. Functions or methods. Okay. Any questions so far? Any questions so far? There's no question. Let's take one more example. Let's take an example of classes and objects. I have some images here. Maybe I have to update them. It's Messi winning the World Cup. Now Messi didn't win the World Cup, so we have to update it to someone else who won the World Cup recently.
Lamine Yamal.
I knew the Barcelona fans would speak.
Asante.
Say Cucurella.
Say,
Say
All right.
Cucurella.
Ronaldo.
Double.
Number 16.
Ronaldo.
Rodrigo Casca.
Ronaldo.
All right. So,
William.
Bright, you have a question. You can unmute and ask your question before we
Okay,
look
so,
at the example. Yes.
so I want to ask that. So if you write public class main, does it mean that the main is an instance of the class?
You are going too far. Let's take it step by step. Okay.
Okay,
Yeah.
sir.
So we just want to understand in at its basic level what we mean by class, what we mean by objects. Then we can now associate that with our Java program when we write our Java syntax, what we are trying to do. Okay. So we'll come to that. All right.
Okay.
So let's take an example, another example, just a simple one. Let's say the class is a student. Okay, so let's say, yes, class is student. Class is student. So what do you think will be the attributes? If you know, you can just raise up your hand and then mention it. Anyone? Yes, Bismarck.
Yeah, like history grade, like the level of either level 100 or level 200.
Okay, level. Mark Mensa, your hand was up.
Okay, gender.
Gender, okay. Patrick.
Course.
Pause. Okay. Pascal.
Say, the person's gender.
Someone has mentioned it.
Okay, so we can talk of Assam.
Michael Mensa.
Say please each.
Yeah, sir, please talk of the program, the students of in the program.
Okay, so I heard age, I heard program.
Student ID.
Student ID. Okay, so let's end it here.
Student.
So the program.
Sir, please, I have a question.
Let's add the last one, name.
Sir,
I'm surprised you mentioned all this without mentioning the name of the student.
sir,
Yes, if you have a question, Pius, kindly raise your hand and then.
okay, please, I'm sorry.
Okay,
But
so go on, yeah.
please, I wanted to know that is there a difference between the course and program?
Yes, there's a difference.
Okay.
So your program is HND Computer Science. The course are the various subjects you are offering in the program. You get it?
Yes, sir. Please, thank you.
So you are doing computer hardware, you are doing object-oriented programming, you are doing discrete maths and so on.
I have a question.
Okay. All right,
Yes,
so
sir.
let's move to the
Sir,
behavior.
please, I have a question.
Yes, Jonathan.
Okay, so say with the name earlier on, you said the name falls under objects. So with the attributes, when I'm seeing a name here. So what's the difference, sir?
All right. I think this is a good question. Okay. So there's
So
not
can I answer?
always someone wants to answer.
Yes.
Okay, Benjamin, let's go.
Okay. So say I think for the attribute, the name is general, given as the name or the title. But when it comes to the behavior or when it comes to the object, it deals with the individual name, Ama Kojo or Clement.
Okay, that's a good attempt. Okay. So the name can let me put it this way. The object is trying to identify a particular entity. Okay, so who asked the question again? I've forgotten the name.
Sir Jonathan.
Jonathan. Okay. So the object is looking at a particular entity, a unique entity. I think something unique about unique showed up in the document as we were going through. A unique entity. Okay. So yes, it wouldn't be all the time that you see us put an object there as a person's name. It's not always the case. Okay. But what we are doing is trying to identify a unique entity. Okay. Or create a unique entity. Let me put it that way. Okay. So the example I gave earlier, a 3-bedroom house, which is a class, okay, you want to build a 3-bedroom house. Someone can build a 3-bedroom house and build it such that each bedroom is on one floor. So you are going to see a 3-story with a bedroom on each floor. It's a 3-bedroom house. So that's an object. That's one object. Another person will build a 3-bedroom house with all the bedroom without it being even one story. Okay. And it's still a 3-bedroom house. So that is an object. Okay. So it's unique. Just that it should meet the attribute, or it should satisfy the attributes and the behavior of the class. Are you with me, Jonathan?
Yes, sir.
Okay. So let's take the behavior for this one. If you are ready, you can raise your hand. Maybe let me give you one. I'm sure when I give you one. So one, I'll say, has registered. Now, anytime you write a method or a behavior, you end it with an open and close bracket. That is what distinguishes behaviors from attributes. Okay, and we'll get there. When we talk about methods and all that, you appreciate this, what I'm talking about more. So has registered. So what it means is that over here, we want to tell whether the student is registered or not. So this is going to be a Boolean operation. True. True means the student has registered. False means the student hasn't registered. Okay. Yes, any other? Bismarck?
Like makes noise.
Pardon?
Like makes noise, like a noisy student, like someone makes noise.
Okay. Are you a noisy student?
No, not at all.
Not at all. Okay.
Yeah.
Okay. Isa?
Sir,
Yeah.
has taken exams.
Okay. So taking exams. So we'll take the last one from I need a lady.
Sir, please, my hand is up.
Are you a lady? I said I need a lady. Since we started contributing, I've not heard any lady's voice today. So I need a lady. In fact, computer science, we are encouraging our ladies to be active in every session. So I need a lady. Augustina, yes, I see Augustina's hand up. Augustina,
Sir,
yes. One
please,
behavior.
can it also be whether a student performs good in class or performs very badly?
Okay, so we can say performance.
Okay.
Okay, that's a good one. Okay, so what we have here is a typical class. Okay, so we just developed this class for a student. Okay, now I want to come up with an object of that class. So to defeat the claim that we are using someone's name as an object, we'll say student A. Jonathan, are you here? Is it Jonathan Tete? Are you here? Or he's gone off the call. So his question was that why are we using why do we choose the name Clement Mensah as an object? Okay, and I've explained that already. So like I said, it's not mandatory that you always use a name. Okay, it's just a unique entity. So student A or student 1 can be an object of the class student. Okay, so if it takes student 1 should have a level. So maybe student 1 is in level 100. Student 1 is a female. Student 1 is doing CPS 104. Student 1 is 19 years. Student 1 ID is 025 1111D. Student 1 program is HND Computer Science.
Student 1 name is Patrick.
Patrick, a female Patrick, eh?
Yes, sir.
So student 1 is Patricia. Thank you. Student 1 is Patricia. Okay. So now take notes. we said that what? The attributes are also considered as what? Data, right?
Yes.
So if they are considered to be data, then that means that these values here should take up a particular data type. So the level will be what data type?
Integer.
Integer. Then the gender with F will be what data type?
Character.
Thank you. Then the course code will be what data type?
String.
String.
Which is a collection of characters.
Yes.
Then age.
Integer.
Int.
Then student ID.
No, string.
Student ID will be a string.
String.
Yeah, string.
Because we have a D in the ID.
Yes.
Then the program.
String.
That one too can be string.
No, it should be char. Char.
No. Char is useful to store one, like single
Only one single alphabet.
Yes.
So a string is a collection of characters.
Yes. So string.
So it's going to be a string with the double quote. And then the name is also a string.
Patrick is a string.
Yes. Sister Patrick.
Are you following?
Yes, sir.
Now, I want you to read on this UML class diagram. Okay, so read on this before we meet. Next week, we are meeting face to face. So the morning, we'll have our class from 11 o'clock. And then the part-time, we'll meet at 7 p.m. Okay, so read on this UML class diagram, Unified Model Language class diagram. Okay, go and read about this. You understand what we are doing at the moment, adding the data types to the data that we claim are the attributes. Okay. So now we are on the behavior. We said behaviors are methods or functions. Mark Mensah, your hand is up. Do you have a question? All right, so the first behavior here is saying that is has registered. So this, if you look at this function, we want to assume that the statement in this function block is a Boolean statement which will require a yes or no or a true or false answer. Okay, so is Patricia registered? So let's say yes, because if you are not registered, we will not know your course or your program you are offering. Does Patricia make noise? No. So we assume that's also a Boolean expression. Has Patricia taken exams? Yes. Okay, now the behavior states, the behavior is not only about yes or no, or true or false. Okay. So Patricia's performance, so we can say she's a first class student from her level 100 results that were just released last week. We can say that Patricia, it has a GPA of 4.99 Are you following? Okay. All right. So for each method, there's also a data type that uniquely describes it. Okay. So for this one, we can say is bool. We can also say declare this as a bool because we want a Boolean answer. Taking exams, we can say this is void. Okay. And then performance. So performance, we can also say this is void, where we probably just want to display the student's GPA, okay, or the performance of the student. Are you following?
Yes, sir.
Yes, sir.
Yeah. So what we've done here is simply to declare, to create an object, which is an instance. So student here, we'll say that student is an instance of the class student. Sorry, student A is an instance of the class student. Are you all with me?
Yes, sir. Yes, sir.
Okay. So I see a hand up. Let's take these two questions from, is it Kojovi and Mark? And then we'll move into our code to
Okay, sir.
demonstrate how this concept works in Java programming. Yes, Mark first.
Okay, sir. My question was, please, what does the void stands for? Or what's the meaning of the void?
Okay, so let me explain it here, but we'll talk more about that going forward. I believe you've done functions, right? In C++.
Yes, yes, please.
Yeah. And one of the functions you know of is the main function. I think I explained this in our last session. So
Yes, sir.
in Java, in C++, you did int main, right?
Yes, sir.
Now, because of the int here, you see inside your curly brackets a return
0.
0. Yeah. Okay. Now, anytime you use a void, which we'll do in Java. So Java, you see void main.
Okay.
Public static void main. That's the main method. So
Okay.
in Java, the void has no return value. Void has no return value.
Okay.
So in Java, you will not see any return 0.
Okay.
Okay, that's because we use void.
Void.
Okay.
Okay.
So anytime you see a method where they use void, when you look at it carefully, you see that there is no return value in there.
Okay.
But if you use Boolean, you use char, you use float, you use double, you use int, you would always see a return value. And the return value should be the value, okay,
0.
in this case, should be an integer value. If your data type is Boolean, then you should be returning a Boolean value, true or false.
Sure.
Do you get it?
Yes, sir.
Okay.
Thank you, sir.
You're welcome. Let's take Kojovi. Ojobi, you can unmute and then ask your question.
Okay. All right. Good evening again.
Good evening.
All right. My question is that shouldn't the name of the student be part of the attribute?
Shouldn't the name of the student be part of the
Be part
attributes?
of the attribute.
Yes, the name of the student
Yeah.
is part of the attributes. It's here.
Oh, all right. All right.
It's already here.
I couldn't read that well. Thank you very much.
Okay, you're welcome. All right, so with all this rough work we've done here, let's quickly switch into our IntelliJ, create a program, and then write some simple code. But before that, let me take you through the basics. Next week, when you come for your face-to-face, your lecture notes will be ready. Okay, so unfortunately, I've not introduced my teaching assistant to you, but hopefully next week when you come, I'm sure we'll meet each other for the first time. And then I'll do the necessary introductions as well. So let's look at the basics. These are things that you know already from C++, basically the same keywords and so on, okay? All right, so we said in Java programming, nothing can exist outside a class. Take note of that. In Java programming, nothing can exist outside your class, okay? And the class is the unit of a code. That is the basic building block of your Java program. So in every Java program, we have a public class. You create your class, give the class a name. So hello class. Now in that class, there is a method. Okay, and it's the main method. And without the main method, you cannot run your Java program. So every Java class has a method, or your Java program should always have a main method. And you can see the main method here is void. Okay, void meaning that there's no return value. Okay. Then we have a statement here which says system.out.println. Now this statement is basically printing out the statements. In C++, you would have C out. Okay, in C++, you have your C out. And then you would have said hello world. Okay. So it says this program defines a class called hello. Oracle has established the convention that the class names always begin with a capital letter. Okay, so the class names begin with a capital letter, which makes it easy to recognize them. Okay. Java requires that the class name and the file name match. So your file name and your class name should match. That's to say that when you create, in fact, what happens is that when you create a class, automatically that class creates a folder. We saw that last week, our last face-to-face. I'll make the videos available on the LMS. I'm setting it up. So we saw that there was a folder that was created. In that folder, when you open it, you see the file, and the file is named as a .java file. Okay, so as we can see here, the file name must match the class name. Must match the class name. All right. Now, so basically this is the syntax for a class. So first you have your public class, then you have your methods. So you can have multiple methods inside your class. You can have multiple methods inside your class. Now I said the first line of the class is known as the header, the class header. So this is the class header, the first line. Then the word public in the header class indicates that this class is available for everyone to use. It's available for everyone to use. Okay, notice that the program code in the class is enclosed in curly brackets, as you can see. So it said these characters are used in Java to gather together related bits of code. In this case, the curly brackets are indicating that everything defined within them is part of this public class. Okay. Now, like I said in our last meeting, the public here is what we call access modifiers, and we will talk more about it when we look at classes and objects later in the course in details. Okay. Then we have methods. Okay, so what's a method? A method simply is a program unit that represents a particular action. Okay, please hold on just a minute. All right, let's go on. So a method is a program unit that represents a particular action or computation. Okay, a program unit. So simple methods are like verbs. Like I said earlier when I talked about the behavior and the fact that they are actions and reactions. Okay, so the methods are like verbs, and they command the computer to perform some actions. Okay, so inside the curly brackets of a class, you can define several methods inside the class. So as you can see in this class, we can have one method, another method, and so on. Okay. Then at minimum, a complete program requires a specialized method, which is known as the main method. Okay, so in Java, we have the public static void main. A public static void main. For short, we say PSVM. PSVM. The code intelligence will just bring up the full text. So I'll just skip through some of these things. When you get the lecture notes, you can read them yourself. Then we have a statement. So the statement system.out.print is the output statement. Okay, and then it's terminated with the semicolon at the end. Then we have string literals. String literals. Okay, so it says when you are writing your Java program, such as the hello world, you will often want to include some literal text. Okay, and this literal text will be sent to the console's output. So like the hello world that we put in the system.out.println is just going to show as output. And programmers have blah, blah, blah. Yeah. Then we have what we also call, yes, we have, so it can come in this form, as we can see here, okay, surrounded with quotes. Then it said you must use double quotes, not single quotes. Take notes. You must use double quotes, not single quotes. So the single quote will look like this. So this is preferred. Okay, I know maybe some of you've done Java, you've done Python before you've learned Python on your own before you are learning Java. In Python, it doesn't really matter whether it's double or single. Okay, but when you come to C++ and C, the syntax of the code is such that you should always use the double quotes when you are doing the string literals. Okay, the single quote is referred for characters, single characters. All right, so then escape sequence. I believe you know escape sequence from C++. So with the escape sequence, we have the \T, that's the tab, \B, backspace, \N, new line, R, which is the carriage return, F, form feed, then the single quotes, and then the double quotes. Now, this is over here because imagine you are writing a character of a single quote inside a string literal. Okay, so maybe you are writing this and you want to put a single quote around the surround in this form, where we already know that the single quote is going to handle it as a string literal. Putting it here will give you an error. So what do? You just put the / first. So that what you do is that when it's outputting your text, it will output the surround in a double quote or a single quote. Okay, and it wouldn't capture it as an error. Then we have the double /, which is going to give you the double \, which will give you the \. Okay, the \ in your text. Okay, so a typical example is what we see in here. So you can see the system.out.println. We want to print the characters, put it in double quotes, and then bring a \ before the print. Okay, and then the \n, that means it should print this, then move the produce 3 lines onto the next line. Okay, so it's going to give you this. The output will look like this. So this produces 3 lines. 3 lines of outputs. Are you following?
Yes, sir.
Okay, so this is so because of the \n here, and then the \n here, which is new line. This also have the / double quotes, and then the \\. Now we'll be using this. So if those of you who have watched the video I shared with you last week, you realize that in that video, they had to use this escape sequence in printing the receipt or the invoice. Okay. And it's something we will also have to do. So Java has what we call a variation of print line. Okay, print ln. So this is print line. Print line. So the line has been shortened a short form of the line is what we see as LN. Please, it's not I, it's not capital I. It is LN for line. Okay. So what it means is that, so we have print and we have print line. Okay. Anytime you use print, it prints the text on the same line. But anytime you use print line, it prints the text and then moves the cursor to the next line. Okay, moves the cursor to the beginning of the next line. That's the print line. Okay, so take note of that. Then we have also keywords and identifiers. So we know identifiers are words used to name parts of a Java program, or they are given to an entity in the program, such as a class and so on and so forth. Then we also have the so identifiers. In fact, there are rules of identifiers. I don't know if you were taught some of these rules. Were you taught the rules of identifiers?
No, please.
Please, we learn them ourselves.
Okay. So the identifiers have rules. One of the rules is that first, identifiers are case sensitive. So the fact that you write class with small c and class with capital C, and the whole letter in block letters, or the whole word in block letters, they are all considered to be different. They are not the same. Okay. Then another rule is that you don't start an identifier with a number. So instead of writing an identifier first name, you do not write first, as in one S, T, name. This is wrong. It will always give you an error. Okay. And then you don't also separate them. Anytime you want to separate, you use an underscore, as we can see here. So hi there. This is a valid identifier. Number students or number of students are valid. Like I said, you don't start with the number. So you can put the number anywhere apart from the first statement. Okay. Then in illegal identifiers, so you can see here, 2 plus 2. You don't use the only symbol that you can use in your identifier. In fact, there are only 2 symbols. That's the $ and then the underscore. Even that, the $ in some cases might give you error. Okay, but mostly the underscore. Then you don't keep a space between them. So this is error, wrong. This is also error. Hyphen, which is also error. Okay, then 2 by 2, you are starting with 2, which is also illegal. Are we all here?
Yes, sir.
Yeah. You know, a student had this problem. It was one of these days, they were writing my exam, Java 1 practical exam at the lab. And this student was creating a class. And the class is also identifier. The class name is identifier. So I usually give a directive of how you should create a class name. So maybe the class name should be the project, what the project is about, and then together with your ID, student ID, so that anytime I see the class, I know that the class was created by so and so students. Okay. And people create the class. So let's say the class name is hello, and then your ID. And this person created the class and was separating the two words. So let's say hello world. So he separated the two words as a class name and kept clicking on enter. The thing was giving him error. The lab technicians came over. They were not too sure what was going on, so they couldn't resolve the issue. And this student was there 30 minutes after the paper has commenced. The student was still sitting there, watching the screen, complaining that the PC has an error, the PC has an error, and the lab technicians are not minding him. They don't know us. So I was doing my usual checks, going through to the venue to check whether that student had issues, and I encountered this guy who has been sitting there for the past 30 minutes, couldn't create a class because he claimed the PC is not working. The PC has frozen as usual, what people will say. Wherein this is the case, this student is not writing the correct identifier for the class. Why? Because he wrote the first word, gave it this big space, and now added the second word. And it will never work. It will not even allow you to proceed to the next page.
Wow.
So this guy was just there for the past for over 30 minutes and couldn't write anything. And once I saw it, I knew that this person has never attended my lectures before. Because the same way I'm teaching you, that's the same way I taught them. And we practiced it in class. So if the basics of things is a problem for you, I'm wondering what he would have even written as the code. Okay, so always take note of this, identifiers and keywords. And also another rule, you don't use a keyword as an identifier. Okay, for instance, class. Okay, class is a keyword. Class is a keyword. So public class, public is a keyword, class is a keyword. So you don't use them as identifiers. Class with a small c. Okay, you don't use them as identifiers. Okay. I think we may have to reserve the programming for next week. Okay, when we meet face to face. So that we don't go late into the night. Let's understand all these concepts so that next week when we come, we know that we are just writing codes. And then we have comments. Pius, I'll
Sir.
come to you shortly. So just hold on. Well, you have two accounts. One is for raising hands, one is for speaking there. Interesting.
Yes, sir.
With your double attendance, you still score only 1 mark for attendance. So.
Yeah, it's because my laptop's speaker is not working. Sorry, my microphone is working. That's why.
All right, sure. I thought you wanted 2 marks for attendance. You clone yourself so that.
No, please.
Okay. So we have comments. So comments are text that programmers include in program to explain their program. And I like students who comment their code. It's a good practice. Going forward, you realize that sometimes you've written a code, you've written some program, and you come back to it, you revisit the program after some weeks, and you're even confused. You ask yourself, hey, this program that I wrote, what is this particular line even doing? I don't remember. But when you're able to comment some of the difficult statements in the program, anytime you revisit the code, it's easy to remember what you've done. Okay. Then we have errors in our program. So we have the syntax error, which occur when you misuse the Java syntax. A typical example is the file name doesn't match the class name. You remember I mentioned it earlier, that the file name should be the same as the class name. Then some misspell words, especially keywords, when you misspell them. Then when you don't use semicolon. Okay, and I know that will be one of the error I usually see at this level. People type and forget to add semicolon at the end. It's like you have made a statement, you are writing the essay and you don't put full stop at the end of the statement. Okay, so someone sees it. So there was this story when we were young, basic school, our teacher told that he said someone went to England and wrote, God cursed the queen. This time we'll say, God cursed the king. Okay, wrote it on the wall, God cursed the king. Oh, sorry, now I dictated, hey, you are insulting the king, you are cursing the king, blah, 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 blah. Then they called the person and probed further. He said he wasn't done with his statement. Why? Because he didn't put a question mark there. So they should allow him to complete his statement. Then they allowed him, and he wrote, God cursed the queen's enemies. And added a full stop. Okay.
Wow.
So,
That's powerful.
yeah. So programming, I know some of you write your statements, then you will not put your semicolon there. And the compiler will see it as an error because you've not completed your statement. So we don't know whether you want to add enemies there before you put your semicolon, whatever you want to do. So I'm sure I'll be seeing a couple of this error when we start writing our codes. And then not forgetting a required keyword. Okay, so forgetting a required keyword also can lead you to syntax error. Then we have logic error, which are bugs, so they occur when you write when you write code that doesn't perform the task that is intended to perform. So the logic doesn't follow. So the process of finding and eliminating bugs is called debugging, which we will do that. Then runtime error, which is also a logical error, but severe in the sense that it stops your program from executing. Okay, so in Java 2, we are going to learn a concept in programming known as exception handling. Now, exception handling is key to avoiding runtime error in your program. Runtime error is such that your program looks perfect. There's no syntax error in the code, but when you run it, the program stops abruptly. It just stops. It doesn't give you your output you are looking for. Okay, so that's runtime error. And one of the ways of handling is the use of if-else statement or the use of what we call exception handling. And we'll learn more of that in Java 2. That's next semester. Okay. All right. So next week, we'll try out some of these codes, talk about data types. In fact, these are things you know already: operators, operator precedence, and associativity. Maybe I'll spend time to talk about that. And then we'll write some codes. Yeah. All right. So any question? I don't want us to go beyond the time. The class will be boring. I know some of you are sleeping and snoring already. Just that your microphones are muted, so we can't see you. Yes, Patrick.
Yeah, hello, sir.
So you
Please.
see, they are sleeping.
Hello, sir.
Yes, Patrick, please.
Yeah, please. My question is that in our first semester, our C++, when you run your code and after you execute it, you'll be seeing some errors in C++. But I want to ask, in Java coding or in this Java, when you run your program, will you also when you make mistakes in your coding or in your programming, will you be seeing some errors, mistakes as C++ was given to us? Will this Java also gave us the same errors or like that mistakes when you made a mistake in your programming, please?
Yes. So every editor is able to report on an error. Okay, sometimes it doesn't tell you which type of error it is. Sometimes they're able to tell you it's a syntax error and all that. But there'll always be a message there. Mostly the message will tell you what the error is. It will lead you to the line where the error occurred. It will lead you to the column where the error occurred. Okay, so that's how you read your error message. And I take keen interest in reading error message because it's one of the ways you learn how to program. Some of my exam questions, I'll give you the code with errors and tell you to rewrite the code. Okay, so you should the fact that you write a code and you see an error doesn't mean it doesn't mean you have to lose interest in programming. If you don't make mistakes, you can move to the next level of your life. Okay, so the errors are important. Okay, there's no programmer who hasn't encountered an error in his or her code before.
Okay.
So the error will come, but it's up to you to be able to read it, identify it. Yes, not all error, you can't understand all the error. That's why before ChatGPT and this LLMs and came, there was Stack Overflow. So people go there, to find out what this error. You Google it, you see, this error has occurred. People have encountered this error this number of times. How did they resolve it? So you just go through those steps in resolving it. All right, let's take Pius and then Joseph, and then we can call it a day.
Okay, sir. You see, when we are talking about the past that you said, we can't use keywords.
Yeah.
So I wanted to ask that when the you said that when because we can't use keywords, you said we can't specifically use keywords that start like class like this. You can't use class that begins with small letter C, right? So I wanted to confirm if we can use the class like the word class that begins with a capital C.
Yes.
Okay, thank you, sir.
Keywords, in fact, for every programming language, the keywords, you can do a Google search and look for all the keywords in maybe Java programming. You realize that they all start with a lowercase. Okay, public, class, yes, all the keywords, a whole lot of them. Okay, so and you realize that they are not case sensitive. Identifiers are not case sensitive. So maybe I want to declare a class, public class. Okay, so I'll say public class. Now, when I get to this point, I'll use a capital C.
Okay.
Now, the capital C makes this an identifier, not a keyword.
Okay.
You get it?
Yes, sir.
So sometimes you may want to use a word, but that word is a keyword. So just change
the case,
one of the case, yes, of the word, or you can add an underscore before the word, or you can put a number after the word to make it
a different word.
An identifier, yes, an identifier in that case.
Okay,
not
please.
A keyword. Yeah. Okay. Then the last question from Joseph. Patrick, no. Last question from Joseph. I have some project students waiting for me, so please let me take Joseph's question, and then we end for the day.
So, sir, please, I want to talk about the receipt, the link that you gave it to us to practice on it.
Yeah.
When I did it, I get most errors in my what is the name? The Java that I typed. But some of the errors that they give me is variable amount to pay is never used. And I want to know why that statement is being used.
Okay. So it will be part of what we're going to look at next week. Next week we have a lot to look at. At least we should leave the class by you should be able to cover all these things together with the receipt part. I'll just do a simple part of that code with you in class, and then you take it up and build it to another level on your own. Okay, so I'm sure when we have that lecture, all these questions, Joseph, that you have will be answered.
Okay, sir.
Yeah, so please don't miss next week's lecture for anything. If someone is even going to give you $10 billion, tell the person I'll not miss my lecture next week for $10 billion.
Okay, sir.
All right. Thank you all very much. God bless you. Pray we all have a good night. The Lord see us through the night. May His angels keep charge over us.
Amen.
And may we wake up in good health tomorrow for
Thank you.
another day. God bless you.
Bless you too.
Have a good night.
Same to you, sir.
Like, public,